All right, the first new keyword is called continue, and what that one is going to mean is it's going to skip. It's just you say the word continue inside of a loop with a semicolon, and it's going to skip an iteration of the loop, just like continue to the next one. I don't want to stop, but continue to the next one because I don't like this current iteration. All right, so let's have a demo of that with like a for loop where we're printing from 1 to 10 normally, but let's pretend that like we hate the number 3, so we'll skip over 3 with continue. Okay. So that's a useful thing to have sometimes. So I'll call this file continue and break.cpp. So make it a little bit bigger. Let's make a loop that just like prints from 1 to 10. We know that one. Let's use a for loop. For int I equals 1, I is less than or equal to 10, I plus plus. That'll range within the values that I care about. And cout I. But let's say that I hate the number 3. So if I happens to be 3 right now, I'd like to skip this iteration of the loop. Just like don't get down to here to print 3 because I don't like 3. All right, 3 has wronged me in some way. So I'll say continue just on a line by itself, and what this will do is it skips the rest of the loop body and goes to the next iteration. All right, so it'll just do the I++ and make I4, and like it's like 3 never happened. All right, we're skipping 3 with continue. So that's the relevant code. Let's compile and run this. There goes. So if I, drum roll please, if I scroll up, you see 1, 2, 4, 1, 2, 4, 5 all the way to 10. So that's pretty nice. Continue is going to skip one loop body. Just from where it says continue, it does not do the rest. It goes straight to the increment and continues. Okay? So that's that one. The next one you'll use more often, probably. Break is the more important of the two. Break stops the loop completely. It exits the closest loop that you're in. All right. Think of why I'm saying that. That will foreshadow the rest of this lecture. So it's just another thing that you can say on a line by itself. You say break, that will stop your current loop. All right. And so this is useful for when like you're not sure how many times you want to loop. So for example, maybe we're going to get a bunch of characters or something from the user, and we'll do something with those characters. But when the user types Q for quit, we want to stop getting characters from them. We're not sure when the user is ever going to type quit. Maybe that'll be 100 characters from now. Maybe it'll be 1,000 characters from now. I'm not sure. But I want to be ready for it. If they ever type Q, I want to stop my loop. Okay? That is a decent example, I think. So let's make a program that asks the user for some characters forever, while true. Watch this. While true. This is normally an infinite loop, isn't it? So go for as long as humanly possible until I break out of you. Okay? That's the beauty. So see and ask the user to enter a character, or Q will be the special character, meaning we want to quit out of this and stop our loop. Right? Stop giving me a chance to type characters. So I'll make space for the character the user types, get it with CN, and if that character that the user just typed for me was the Q character, single quotes, remember. If it was the Q character, then I'm done. I want to break out of the loop. Break. So stop the loop entirely. And this is nice because this would normally be an infinite loop, right? I don't know when it's done, only when it's Q. Only when the user types Q is it done. Otherwise, if we're still here, if we keep going after this, we didn't break out of the loop, we can do something with that character that we got. And you can imagine that you could do something fancy, like put it in a file somewhere, save it for later, but we'll just print it back out for fun, right? You typed that character. Why not? All right, so break is going to stop our loop whenever this condition happens. All right, so we're not sure when. Could be a million iterations from now. This would otherwise be an infinite loop if they never typed Q, but we're giving them the chance. Right? So A, B, C, D, E, F, G. Whenever you're done, you type Q, you hit this, it's true finally, and it breaks out of the loop, and that is going to let the program stop itself. Okay? Because that stops the loop. Any questions about either of those two new keywords in C++? Only work inside loops, though. These guys only work inside loops. All right. No questions? Yeah. Yes, it skips one body of the loop from where you say continue onwards. So I say continue, it skips this guy, so it doesn't print the through. Okay? Yeah. Yes, it does not stop the loop entirely. It stops that iteration of the loop. That's the key. That's the key difference between continue and break. Yeah. If we're good enough, let me give you a fancier example. Let's calculate that fancy number e if we didn't have a library function to do it for us. So there is a infinite series sum that converges to e, and it'll be close enough for our purposes. So here is a formula that calculates e. If you add up all these sums, so hopefully you've seen the summation before. This is the idea. It's like a mathematical for loop, essentially. It's like start your n at 0, and then do 1 over 0 factorial, and then just keep on summing, sigma for sum. Add up 1 over 0 plus 1 over 1 factorial, because you're going to increase n. 1 over 2 factorial plus 1 over 3 factorial, all the way to 1 over infinity factorial, which is a very small number. If you do that infinitely many times, you will get perfect, precise e, but inside of a computer, we only have 16 digits of precision for every double, so we don't have to go that many times. So let's go up to n equals 100, and that will be a very, very good approximation for e, better than a double could even hold. All right, so let's do that sum. Does that kind of make sense? We'll range between n from 0 to 100, and we'll add up 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial. I hope that makes sense. So we'll start a sum variable, have it hold 0, and then every time I'm looping with a new value, I'm going to shove that into sum. All right, so I'll calculate that my current term equals 1.0 over the factorial of n, right? Because n is going to be changing each time. First it's 0, then it's 1, then it's 2, and so whatever that is in my current iteration loop, add that into sum. And if I do that 101-ish times, from 0 to 100, then we have a very, very good approximation for e in the sum variable. Okay, so that's going to work. And let's see how to do it. All right, I will use a for loop. So let's do the loop itself, and then actual factorial does not exist in the C++ standard library, so I'm going to have to make that for you. e.cpp. So, but here's the idea. So we're going to start a sum variable at 0. Double sum equals 0. E is it's a number with decimals, so use doubles. And then I'm going to range from n being starting at 0 all the way to n going to 100. All right, so 4 int n this time. Starts at 0, n less than or equal to 100. So it goes to 100, n plus plus. You can see my muscle memory. I keep typing I. So, all right, what I want to do each time I have a new value of n, I want to calculate 1 over n factorial. That's my current term. Current term of my summation, 1.0 over the factorial of n, whatever that is, and then I will add that into my sum variable. Sum plus equals my current term. Do that enough times, we're getting closer and closer to e. Remember that this syntax is just shorthand for sum equals sum plus current term. Okay, so that's what's going on there. And then by the time this is done, we have a very good approximation for e in the sum variable. Okay, so any questions about how I translated this to this? We still need a factorial function. All right, so I have not taught you how to make a factorial function, so you can look away if you're scared. I will eventually teach you how to make your own functions. I'm going to write a function right now, okay? So you can learn a little bit of stuff ahead of time. I do need to make sure it returns back a double because we can't fit the right answer for factorial of 100 in an int, surprisingly. So, okay. Shield your eyes if you want to. Factorial is a function that asks for, we want an integer factorial. Factorial of 0, 1, 2, factorial of whole numbers, and it needs to return back a double to me, even though the answer for a factorial is always a whole number because of space issues. And integers cannot fit 100 factorial in them, but doubles can, just with some lost precision. So, all right, what I need to do to calculate the factorial of a number is to start a value to multiply into. It's like n factorial is n times n minus 1 times n minus 2, all those things. Or the factorial of 5 is 1 times 2 times 3 times 4 times 5. So it's I'm multiplying together a bunch of numbers. So double result starts at 1. I'll just keep multiplying into results. So 4 int I equals 1, I is less than or equal to n, I plus plus. For all those values, multiply those into results. Result equals results times I. So by the time this loop is done, result will have all the numbers that make the factorial of n in them. N is 5, 1 times 2 times 3 times 4 times 5 just keeps getting multiplied into results. I'm going to give back that as my answer. Return result to whoever called me. So that's a function. I will teach you how to make those eventually, but we just needed that right now. Cool. Let's use it. That looks like E to me. Beautiful. So yeah, that's a loop that does something useful. This is potentially how there's a constant in the math library that is E, I think. This is potentially how it got generated. That's how you can calculate E inside of a computer. Cool. Are we good with this example? Yeah, absolutely. That's very necessary. We don't like doing everything in the main function. That's going to get cumbersome. All right. If we're good, I have a question for you. Please do your attendance. I will stop that after this question if I can remember. But please go to the written ice page. You guys can get together in little mini groups, talk to each other, say hi, ask about how your holiday went. But here's the question that I want you to answer after you've said hi. So please come up with a good example of an infinite loop, one that's never going to stop. All right? Make it very subtle. Don't make it obvious, like while true. That's too easy. Make a loop that you think should, like at a first glance, would stop, but actually there's something subtly wrong with it. So think about all the ways that you could mess up. That's kind of what I want you to do right now so that you actually don't do that in real life. Okay? So take a few minutes, try that. Give me some good examples of infinite loops, please. All right, another couple minutes. Make sure to do that attendance, though. There must be something really bad wrong. All right, a few more seconds. So think of a good one, press submit, and then we'll take a look. What could go wrong? You can mess up the, like if it's a for loop, mess up the increment. You can mess up the condition. That's an easy one. Potentially mess up the starting value. Let's see. Let's see what we're thinking. Noise. While I is less than, nice. So here's like a loop that does not have a like a counter. Like it's not counting up. It's never changing its value. Good. Very nice. Very nice. I equals 15 is I less than 10 I plus plus. This one will actually run because 15 isn't less than 10. So that loop will not run once at all. I is less than -1. 0 is not less than -1. So again, we have the same problem. This is actually not an infinite loop. So I'm glad I asked. Try it. Let's see. While I is greater than or equal to 1. Yeah, this is a good example. Like a loop that's never going to stop because we're like, yeah, 1 is greater than or equal to 1, then it's going to become 2. Still greater than 1. So good job. You guys are getting it. Let's see here. Yeah, so it's just like with the for loop, though, you got to make sure, like, is it going to run the first time? Yes, yes, it is. Okay, something like that. So, yeah, I think for the most part we're getting it. Good job, good job. And I'm going to stop this. All right. So, back to here. So yeah, hopefully you can kind of see like the kinds of ways that things could go wrong, and now you'll be watching for it a little more vigilantly. All right. So, I just got a couple more examples, and then we're going to do something weird. Remember that pause function that I had at the karaoke example for the start of class? We can use that to make, with loops, to make like animation, because what is animation but a bunch of different frames being shown to you in order, and you take some time to look at each frame. So like in a movie, for example, or maybe you made like a flip book when you got bored in elementary school. I know I did that. If you just show a piece of paper that has one star on it, and you flip really quickly to a piece of paper that has 2 stars on it, it looks like it appeared magically, right? And that's the idea of like, that's how movies work. You show this frame for a little bit, for like a 30th of a second, and then you show this one. That's how animation works, right? So we can use this pause function to stop our program, print something out, stop the program, let it sit there like that for a split second, and then print more stuff out, and it'll look like it's being animated. Let's just like make some falling stars as an example of that. I would like to go to a new file, I guess, called animation. So I want to steal in that function, that pause function, from Lecture 1's karaoke example. Don't worry about the pause function. I had to look it up on the internet anyway. But there's apparently how you make it. Sorry for the noise. I hope that they eventually open that door close to that parking lot. Then we can all get in earlier. That's fun. Okay, so yeah, pause. Let's print out some stars and then like wait for a little bit. So I'll be like 4 int I equals 0 this time. I is less than 10 I plus plus. So I'm not going to print out. Let's see. Yeah, I think that'll work. Is that how I want to do it? Yeah. Yeah, because I'll wait. And here's what I'll do. I'm going to do some printing. I'll see out some stuff. See out question marks. And then I will call pause. I'll stop for like half a second. All right. And then what I've printed will just remain on the screen for half a second before it comes back and prints more stuff. All right. So that's the goal. I'd like to print a single star, please, 10 times. And for this is an interesting little example, star, and a new line, let's say. This is an interesting example of a loop. This is the more common way to loop for 10 times. If you're not actually using I for anything, most programmers like to start their variables at 0 and then go up to strictly less, so from 0 to 9. It's still 10 times, but it's less typing technically because you don't have to type the equal sign. Yeah, so that's probably why we all prefer it. But this is going to loop 10 times, printing a star, stopping for half a second before it continues for more. Okay. Animation. So watch star. Look at it grow. It's like falling snow. It's so beautiful. You can't really see much as it like cuts off my terminal. You can't see it like go up or anything. But that's kind of cute. We can also have the little piece of snow being like blown over by printing out some spaces at the start of that. Here's a way to quickly make some spaces. If I say string, just the type string, it will make a special kind of string for me if I like call the type name like a function almost. I would like a string of I many space characters. So that's something I can do, okay? I'd like a string of I many space characters, and at the start on the first line, I will be 0 space characters, and then the star. And then on the next line, we have 1 space character, and then the star. Do you see how that's going to kind of print over? Like it's going to blow over the star each time? So kind of watch what's going to happen here. Like when I is 2, it's going to make a string of 2 spaces, and then print the star after that. That's kind of nice. So now it's getting blown that way, which is fun to think about. If you only showed like one line, maybe it looks better that way. There it goes, being moved over. But in reality, we're printing this. That's kind of cool, right? So yeah, just loops give you access to cool things, and I hope that you find it fun as well. Okay, that's just a silly example of the power of loops. Yeah, any questions before I move on to something else? I'm very sorry about the noise. All right, let's see here. So it's time. It's time for a hard concept. I'm sorry. It's something you got to learn. We'll work through it together, but I want to give you nested loops now. We need to learn about them. So when you put a loop within a loop, it's just more code, right? You knew this was coming. It's going to happen, right? This is traditionally a difficult concept for CSCI 40 students, so pay a little bit of extra attention to the rest of this lecture, okay? So, and ask lots of questions. So, all right, we're going to put loops and loops, because you can put any arbitrary code in the body of anything, so you can put loops and loops. Let's make this happen, all right? So the way that I want you to think about it is like, all right, this while loop, what is it doing? Maybe it has a variable that it's messing with. Like this while loop is messing with I. It starts at like 1, 2, goes to 3, goes to 4, goes to 5, whatever. And then maybe this while loop in the inside has its own little variable. Maybe it has j, and j goes from 1 to 2 to 3, blah, blah, blah. So here's the key thing that I want you to remember. You can just come back and just repeat this mantra until you get it. During each iteration of the outer loop's body, the inner loop will run to completion. All right? That's the secret. And so, for example, when I is 1, if I is 1, we're going to run the entire body of the outer while loop, which is going to run all of this code, which is itself another while loop. So this will run completely. It will span through all of its j's. And then we'll come back, I is 2, we'll do it all over again. Okay? That's what's going to happen. I will walk through it slowly. But this is the idea. All right? This will eventually make sense, I promise. Okay? So here, let's walk through a very carefully crafted loop. And here is a picture of what it's going to output. Sorry, it's a little small. It's going to output those things, exactly these things. I want to try to teach you why it's going to print exactly these things. Okay? So here we go. This is a for loop, the outer for loop. It is ranging with an I variable. I is going from 0 to 4. Yes? And so how many times is it going to run its body? If we didn't know what the body was, how many times is this outer loop going to run its body? Can somebody tell me? It's going to go 5 times from 0 to 4. Does that make sense? So we don't even need to look inside. We know that this loop is going to execute its body 5 times. Okay? And then every time we have an iteration of this body, it's going to run all of this code, which is itself another for loop. Oh no. So every time that outer for loop runs an iteration of its body, this entire body will get executed, all of this code, and that's just another loop. All right? So now what does this do? It's ranging from j from 0 to 4, right? Strictly less than 5. It's also going to run its body 5 times, yes? So also executes its body 5 times. Okay? So, my question for you now, one thing to think about is this innermost line in the innermost body, how many times total will it get run? Given that I know this is going to run 5 times, and each time it's going to run this entire loop to completion, this inner loop to completion, and every time it runs, is going to execute its body 5 times. Can somebody give me how many times this inner line is going to run? Can you figure it out? Anybody else? It's going to be 25 times. So yeah. Does that make sense? It's going to run its body 25 times. This line must, therefore, get executed. This line gets executed. And here's the output on the right. Executed if you didn't know what was getting printed, you know that there's going to be 25 lines. 5 times 5, 5 for the outer loop. The outer loop's running 5 times, and it's running this entire thing 5 times, right? And it's running its inner loop 5 times. So 5 times 5, 25 times. Okay? Interesting fact 1. And then now let's try to talk about why it's going to print 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 1, 0, 1, 1, 1, 2, 1, 3, 1, 4. Let's figure that out. All right, so at the very first iteration of the outer loop, I is set to 0. Yeah, I is set to 0, 0 is less than 5. Let's run the body. So I is set to 0. And then, all right, in terms of running the body, we have to execute this entire loop, this inner loop. So it has its own variable. It has a j. J equals 0. Right, starts at 0, 0 is less than 5, run the body, and print I space j. So does that make sense why we're seeing 0, 0 printed first? That's what needs to happen first. And then this loop is what's running right now. We do the j++. Now j is 1, right? We're running that entire thing to completion. It's not over yet. So j is now 1. 1 is less than 5. Does that make sense why we're going to see 0, 1 printed next? I has not changed. We are working on that inner loop. To run a loop, you have to keep going until it's done. So we got 0, 1 next. Okay? And I think you can imagine that's why you see 0, 2, 0, 3, 0, 4. Okay? That's why we have those lines. And then this loop is done, right? Because it makes it 5. It makes it 5, and 5 is not less than 5. And so this entire loop is done, and also that j belonging to it. So now the j's dead. J's gone now. And that completes one iteration of the body of the outer loop. We have run it to completion, all the code, okay? So we come back, all right, I++. I is now 1. And then we do it all over again because 1 is less than 5, all right? Then we run all this body where we make a j, a brand new j variable, second j, starting at 0, right? 0 is less than 5. Then we run this inner loop to completion because it's just more code. We have to run it all, right? And that's why we see 1, 0. Then j++, 1, 1. Okay? 1, 2, 1, 3, 1, 4. 2, 3, 4. And that will complete this inner loop one last time, a second iteration, right? A second rendition of it, maybe. And then we're done with this body. We can do I++ again. Now I is 2, right? And then we can do 2, 0, 2, 2, 1, 2, 2, 2, 3, 2, 4. Does that make sense? What's happening there? The I is like, it's being increased slower because we have to wait on this inner loop with all of its j's. It has to range through them all first before we can move on, because that's what it means to execute your body. It's a loop. It's got to finish, right? So that's why I will eventually get to 3, 4, right? And then we print 4, 0, 4, 1, 4, 2, 4, 3. The very last thing we print will be 4, 4, because then, like, anything after that, you increment I, now it's 5. It's not less than 5 anymore. That stops it, okay? So that is why you see this exact output, and this is the slide to stare at until you get it, okay? This is what I want you to understand. Go take this code, paste it into the C++ tutor website. This is really going to help, I think, okay? Are there any questions about this code that you can formulate right now? Like a what? Yeah, you can definitely think about it. It's like the inner parts, the minute hand, the outer parts, the hour hand is moving slower. Yeah, is there another question? Yeah, it's just that's part of that's that part of the loop. It has to run eventually. Once it completes the body, though, it's always condition body, which is a big body this time, increment. Yeah. Any other questions? All right. So we've learned some cool things. First key idea that we just noticed, that we don't even care about the output. We noticed that if we nest loops inside of loops, that inner thing is going to be multiplied, right? We're going to run that a multiplication number of times. So nested loops multiply work. So let's use that to draw a box of stars. All right, it'll make it easier. And here's the setup. We're going to have 2 loops. We're going to have an outer loop, and it's going to be so natural. I promise. We're going to have an outer loop, and we're going to have an inner loop. And here's what's going to happen for the outer loop. The outer loop is going to worry about which line we're on. Like, are we on this one, this one, this one, or this one? Okay. It's going to worry about which line we're on. It will end up doing that. We'll write it, and it won't be natural, I promise, which line we're on. That's what's going to happen. And then the inner loop is going to worry about, all right, if we're on this line, we better draw 4 stars on a new line, right? It's always 4 stars on a new line every time we're on a line, okay? So that's what the inner loop is going to take care of. Okay, print a single line of stars. So even if you didn't know this was going to be a nested loop, you can break it down this way. Like, all right, what do I need to do? Because this is a repetitive problem, right? So this is not C++ I'm about to write. I'm about to write English that kind of looks like code. It's called pseudocode. So do you see how, like, if we could just like repeat 4 times the following, we would have our box of 4x4 stars. Do 4 times. If I could just like print 4 stars in a new line, 4 stars and a new line. If this were real C++ code, does that make sense why this would make the box? Yeah. And this is kind of like a loop. Yeah. Any questions about that so far? So that will make this box. If this were actual C++, that would draw the box. Yes. All right, but what is this? This is how the nested loop comes in. Like, what does it mean to print 4 stars in a new line? That's still repetitive, right? So this can be broken down into, all right, keep the, what does it mean to print 4 stars in a new line? Well, it's another do 4 times, right? Do 4 times, print a single star, yeah? Because that's repetitive. Print a single star, and then after that's done, like, I'll unindent to mean we're done. Print a new line. Does that make sense? Like, this is that part, and it's just, okay, it's another loop within a loop. That was natural, right? That's obvious that we want that. And then we'll keep the same thing out here, so it's like, that's kind of what it looks like. We just need to translate it to real C++ now. And so all the indented stuff are bodies. It's like, this is the body of the outer loop, here's the body of the inner loop. But it makes sense, right? 4 times for each of the 4 lines, I would like to print the 4 stars that are on that current line, and then break that line. Yeah? So this is what, if I could just translate it to C++, I would get my box. Does anybody have any questions about that? Do you not see it? That is, if we could just do that, and then the nested loop kind of came out of nowhere. It makes sense, okay? All right, so let me code that up. So that'll just turn into a bunch of for loops that like iterate 4 times. All right, so we've got box.cpp. That's what I'll call it. And all right, here's what I want to do. For, like, what do I need to do? I need to make a loop that's going to run 4 times, right? Make a loop that runs its body 4 times. So like 4 something, something, something. I just need to execute my body. Execute the body 4 times. That's my do 4 times. So I'll just use I for that. Int I equals 0. I is less than 4, I plus plus. So that's going to run exactly 4 times. Okay. All right, that's the outer one. Now I need to do, all right, do 4 times, print a single star. I'll use J for that. So I'm going to print 4 stars, and a new line. So how do I print 4 stars? I'll loop int J equals 0. J is less than 4. J plus plus. See out a single star. Do you see how once this is done, I've just printed 4 stars on my current line? And then I'll break the line, see out a new line, let's say. Okay? So that is this. And it should be happy, in theory. Let's see. Wow! So pretty. So that's that code. Can we kind of see how we started from here? It's like, all right, we didn't even know we needed a nested loop, but we broke down the inner part. It's like, okay, yeah, I'm repeating something again. Okay. So that gives us a box. Isn't it beautiful? All right. If we're good, I would like to give you a question now. So here's this code. You probably want to break it down in the way that I have done it on the previous slide in English first. That's helpful. But you don't have to type this anywhere. Just try it yourselves and help each other. But I'd like you to modify the code that we had. Instead of printing a 4x4 box of stars, I'd like you to print like a hollow box of stars. All right? So like, instead of all the stars all over the place, there are 2 places where it's like a space instead of a star on these inner lines. So it's 4 spaces total. Does that kind of make sense? It's like, what would you change? And where would you change it? So see if you can try that. All right? And ask me if you have any questions. What do you need to change? It's not always see out a star, right? It's not always see out a star. How can you fix that? All right. Now, this is a good time for me to do that. I think you're going to have an if statement, right? What's special? What happens? Right, the outer loop is figuring out which line you're on. So like I is 0 when you're on this line, I is 1 when you're on this line, I is 2 when you're on this line, I is 3 when you're on this line. And then something similar is true about the j's for each star you're printing. See if you can use that to your advantage. No, I don't have to worry about that. Do we see it? One last hint, and then I'll show you my answer. But so I is in control of which line we're on, right? It was always like print 4 stars in a new line, but now we kind of want it to be different. So like when I is 0, this is like what column we're on. J is controlling kind of what column we're printing out on, right? Because it's going 4 times again. So J is 0 there, J is 1 on this column, J is 2 on this column, J is 3 on that column. So can you see, like, you can maybe make a condition to check, like, is I within a certain range and J within a certain range? If so, that's the middle. Yeah. So give you a few more seconds to ponder that before I show you my answer. There are other ways to do it, but this is one way to look at those values of I and J. All right. Any questions that I can answer before I show you the answer? One answer. There's a million ways to do this. So, all right. I noticed that, all right, when I is 1 and J is 1 or 2, or I is 2 and J is 1 or 2, if any of that's true, then I'm printing a space rather than a star. Yeah. So that's kind of what needs to change. So if it's like, when is it true that I want to print a space versus a star? Well, I want to print a space when like I is between 1 and 2. When I is between 1 and 2, like that's the mathematical way of writing that. And J is between 1 and 2. If that's all true at the same time, do you see how like that means I'm in the middle here for the way that I wrote the loop before? So if that's true, then I know that I'm in the middle. And so like we just need to work on translating this from math to C++. Like the and can become the double ampersand. We have an operation for that. And then these guys, sadly, in Python you can kind of do this, but you can't in C++. So like each of these, you can't be like 1 less than or equal to I less than or equal to 2, unfortunately. Instead, what you have to do is you do them separately. Check that part and this part. So it's just a bunch of things added together. Is 1 less than or equal to I, and is I less than or equal to 2. That's kind of how that's going to work. Okay? And so, to translate it properly, it's going to be like if I is within that range, like if I is greater than or equal to 1, I just flip that, and I is less than or equal to 2, and is j greater than or equal to 1, and is j less than or equal to 2? If so, they're within the right range, and that's my space character. I want to print space, if that's ever true. Otherwise, else, that's a star still. Everything other than that is a star. Okay, so that is one way to do it. If we notice we're within the right range of i's and j's, then we should print a space rather than stars, because that's the hollowed out middle part. All right, so what I want to do now, instead of always printing 4 stars, I want to sometimes print stars, sometimes print spaces. Like I need a line that prints spaces too. But never both, it's always one or the other, so I need a condition. So if, or check to see if we're in the middle. All right, so if I is greater than 1 and I is less than or equal to 2, so I is between 1 and 2, and j is greater than 1, and j is less than or equal to 2, I could have checked like if I is equal to 1 or I is equal to 2. It's the same idea. It's a very small range. If so, see out a space. Otherwise, see out a star. So the space can go in here, and the star can go in here. And that should do it. Can I show you the entire code? I'll have to zoom out to do that, I think. There you go. Let's put a new line in between the boxes, because we drew another box up here, didn't we? Whee! There we go. Oh, shoot. I've got to save it still. Now I can do it. There it goes. All right, so if we're in the right range, print a space. Otherwise, print a star. And that's checked on every line before we draw a space/star. All right. Any questions about why that works? So I want to up the difficulty some more still. All right, let's do, all right, we're tired of boxes. Let's do triangles. Let's draw a triangle of stars, all right, using nested loops. So we can mostly modify what we had. Like we can use an outer loop. When I is 0, we'll draw a single star. When I is 1, we'll have to draw 2 stars. When I is 2, we'll draw 3 stars. When I is 3, we'll draw 4 stars. And so I need to make a program that loops, and I repeat the same thing, right? I repeat the same thing and do something different every time, which is going to involve a variable or some sort of calculation. So like on the first line, the body of when I is 0 should be something like this. Draw some amount of stars. And then when I is 1, it should also be draw some amount of stars. And that's what is repeating, right? When I is ranging from 1 to 3, I want to draw blank stars where what I put in blank is the same calculation. So whatever I put here, it's got to be repeated, and it's just the body of the loop. It's got to be the same thing, whatever shiny thing it is. I have to repeat that multiple times, and somehow it needs to do something different each line. So when I is 0, I want to print a single star. When I is 1, I want to print 2 stars. What just happened? Oh, yeah. When I is 2, I want to print 3 stars. Can anybody figure out a mathematical formula for what I could put here in this blank? What could be the rainbow box that's going to calculate the right number of stars to print each line? Can anybody see it? Yeah. Yeah. Do you see how if, like, every loop needs to be the same thing, and so you either need to change variables or use existing variables. Do you see how we have an I here? It's very helpful for us, because it's telling us it's almost the number of stars per line, right? As I is ranging, moving on down, always I plus 1 gives me how many stars I want to draw on each line. Draw I plus 1 stars, draw I plus 1 stars, and then I can repeat that, right? Because that could be my loop now. This could be a loop. This could be another version of the same loop. It's just copied and pasted code. It's the thing that's being repeated. It is the body of a loop. Cool. Does that make sense? Like if I just repeated that, then that will give me my box.
So for the, like, if you were to write this out and say like for I equals 0, wouldn't you need the semicolon? I is less than 4.
Yeah, we're still ranging just like the box program.
And then it would be like if I is like
No, there won't be any if statements. How would you write this program if I gave you a variable called I? How would you draw I plus 1 stars? You just loop. No if statement necessary. Just loop I plus 1 times. Does that make sense? Drawing a single star each time. So that's going to be what it is. Well, let's watch it work. So I'll steal this program. Triangle.cpp. So let's steal the original box code. Boop. So we still want to execute the body 4 times. So what do we want to repeat? We don't want to draw 4 stars in a new line. We want to draw I plus 1 stars in a new line, each line. Okay? So it's print I plus 1 stars and a new line. That's the trick. So how do I change this to print I plus 1 stars? Well, here's where the pattern comes in. So it's always, we start at 0, it's strictly less than 4. This is going to loop 4 times, right? Just like this is going to loop exactly 4 times. If I wanted it to loop 5 times, I change this to 5. If I wanted to loop 500 times, I can change it to 500. So if I wanted to loop I plus 1 times, I can change it to I plus 1. Okay? So that's going to loop I plus 1 times, printing a single star each time. It's going to give me I plus 1 stars, whatever I is, and I get my new line. Okay? Yay, we did it. And this is going to work regardless of what you put here. Like, you could make a size 10 triangle, and it's always going to do the right thing because of this inner part. We've learned the trick. We know the formula now. Okay? Cool, huh? So, yeah, that's a good use of nested loops. Any questions about this code? I think one of the best ways to study after this lecture is to go to that C++ tutor website, plug in all the code that I wrote, and just click next. Keep on watching the variables change and see if you can figure out why they're doing that until you can get it. I think that's a good way to practice and learn. I'm sure your book does some cool stuff too. We've got some animations. All right, so actually, this is all us exploiting this first idea, wasn't it? This is all just us exploiting the idea of like duplicating work, multiplying work. There's actually another cool thing going on in this first example program. The second key idea of nested loops is that they're going to try all the different combinations of values. So like, do you see how every different possibility of 0 to 4 in the first number and 0 to 4 in the second number is being printed out? We are ranging over every possible combination of 1 through 4 twice. Like, this is ranging from 1 to 4, and then each time we're trying every possibility of 1 to 4 for that value that we've picked. We're going to range over every possibility from 1 to 4 and 1 to 4. Or, sorry, 0 to 4 and 0 to 4. Excuse me. Does that kind of make sense? Or every possible pair of numbers where those two numbers are taken from 0 through 4 will appear thanks to this code. So they're trying every possibility for us. All right? And that's going to lead to a cool kind of algorithm. It's called a brute force algorithm. It's a fun name. It's just like we are throwing a computer at a problem because computers are fast. They can do 4 billion things a second. A brute force algorithm just goes through, tries all the possibilities, just doesn't try to be smart about it because your computer is pretty fast. And so this will usually work. All right? So here's my silly problem. We're a farmer today. Or we have a farmer friend, and at the market, Farmer Costco, every horse costs $10 today, every pig costs $3, and rabbits are on sale for 50 cents a piece. Okay, and so our farmer friend comes back and they have a challenge for us. They say that they bought, or she bought 100 animals for $100. All right, she bought 100 animals for $100. This farmer. And she's not telling us which ones, though. All right? That's all we know. So, can we figure out how many of each animal she bought based on that information? If we knew the prices and we knew she bought exactly 100 for $100, can we do it? Yes, we can. The answer is yes, we can. And we can do it with the same idea. I'm going to make 3 variables and loop over every possibility of buying up to 100 animals. So, like, I'm going to loop from 0, 0, 0, 0, 0, 0, 0, 0, 1, all the way to 100, 100, 100, even though that's 300 animals, right? One number will be horses, how many horses I bought. Another number will be how many pigs. Another number will be how many rabbits. Some of these are overkill, like that's too much. But in between, like we're definitely ranging over all the possible answers, right? If we just looped in this way, tried all these different possible values. We just looped in this way, one of these will be the answer, or multiple. Okay? So I'm going to make 3 variables. I'm going to have a triply nested for loop. right? That's what I need to do. Just like this is looping over I and j, it's ranging over different possibilities for I and j. I want to range over different possibilities for num horses. That'll be my variable. It's got a loop from and range from 0 to 100, and then I need num pigs. It's also got a range from 0 to 100, and then num rabbits, right? That's also got a range from 0 to 100. So I need a triply nested for loop, okay, to try every possibility. That's my goal now. So I need a triply nested, that's supposed to be y, loop to try all the combinations, all the combos of the three numbers. All right, somewhere in here is the answer, because I could have bought like 0 horses, 100 pigs, and 0 rabbits. Like the answer is going to be in here somewhere, but sometimes we're going above and beyond. Like we're trying to buy 100 horses, 100 pigs, and 100 rabbits, which is not a valid solution. But it doesn't matter. This is brute force. We're just throwing the computer the problem. Sometimes it's not the right answer. Okay, but do you see how if we range over these possible values and tried every combination, the answer's in there somewhere. You can't buy fractional things. That's one nice answer. One nice reason why this will work. Okay, are we ready? Are we ready to figure out the solution to the puzzle? All right, so brute force. So I'll just use you could use a while loop. I'm gonna use a for loop though. We'll start out with horses. So for int num horses, I could buy 0 horses all the way to 100 horses. So we need that option in there. They need to range in that way, because I could have bought 0 of everything else. Though that won't be the answer. These horses are too expensive. All right, or I need one for, let's see. There. I need one for, instead of horses, I need num pigs. And then I need one for rabbits. Oops. There. All right, so there's my triply nested for loop. And I'm ranging over every possible value. Do you see that when I get into this innermost body, I will have chosen some amount of each of those. All those variables are alive, right? When I am here, I have chosen some amount of horses, pigs, and rabbits. Every possibility within the ranges that I care about get a chance, right? All the way from 0, 0, 0 to 100, 100, 100, and everything in between, right? Every possibility will get a chance. And only some of those are going to be solutions, right? Are there any questions about the fact why, like, do we all see that we're going to have every possible value eventually when I hit here? We're going to hit there a lot of times. Okay. So based on what I have now, I have some choice that I've made. I have some different number of values for each of these. I just need to see, like, did I buy 100 animals? So I'm pretending, right? Did these add up to 100? Have I bought exactly 100 animals? And then I also need to figure out the price, right? So first of all, how many animals did I just buy in this pretend iteration? Animals. This is a simulation, right? Well, I bought num horses, horses, plus num pigs, pigs, plus num rabbits, rabbits. That's how many animals in total that I have bought with these, with whatever combination I'm in right now. And then also the price, which is a double price, because 50 cents are involved. It's going to be, well, the price of this is, well, it's how many horses I bought times 10, right? Num horses times 10 plus num pigs times 3. So every pig is $3. And then rabbits were 50 cents. Num rabbits times 50, all right? And so if it's true that num animals is exactly 100, and then also price is exactly $100, I'm doing something that I told you to never do. I'm comparing a double for equality. I know that it's going to work this one time, right? You're not allowed to do this until you get a computer science degree. Then you're allowed, okay? You don't know the tricks yet. But I can compare a double just this once. I promise it's going to work this time, but it will never usually work, okay? So if that is true about those two variables, I have found a solution. Yay. And I better print it out so that I remember. And I can tell my farmer friend exactly how many things she bought, even though she didn't tell me. Num horses. Num horses. I bought that many horses, comma space. And I'll try to make this pretty. Num pigs, pigs. I'm breaking the line for myself, not for the user. And then I bought num rabbits. Rabbits. And that should be, I guess, a new line. And then we can end it. Okay? So that, I need to zoom out a little bit, because there's a lot going on here. That is my program. There it is. Okay? That is going to eventually find the answer. It's ranging from every possible value, through every possible value, figuring out how many animals we bought, how much the price was. If it matched what we heard, I'll print out that because that's a solution. Okay? Does that make enough sense so far? Are we ready to run it and see the answer? Yeah.
How come you don't want us to do like equals for the and then
You're asking why I did this? Remember that doubles are imprecise. Usually it's not exactly equal to anything. Yeah. But it will be this one time. Just this once. Yeah. You'll learn the tricks in CSCI 45. Until then, you gotta wait. All right, let's do it. Yay! There are actually multiple solutions. There's exactly 2 solutions to this problem. Either the farmer bought 0 horses, 20 pigs, and 80 rabbits, which should check out, right? So that's 20 pigs times $3, so that's $60, plus 80 rabbits times 50 cents each, so 60 plus 40, that is 100. And this adds up to 100 animals, so 0 horses in this transaction. Or the weirder one, 5 horses, 1 pig, and 94 rabbits, which apparently also works out. So 5 times $10 for a horse, so that's $50. 1 pig, so that's going to be $3, plus 94 rabbits for 50 cents each. That does add up to 100. Cool. So there are 2 solutions to this problem, and we found both. We found both thanks to our program. It ranged over every possibility. Some were useless, but it ended up working. Any questions about that now that we've seen the answer? One question you could ask is this as good as we could do? Could we do a better brute force solution? And the answer is yes, we could do better than this. If you've taken a statistics class, you have heard of the term degrees of freedom. There are actually only 2 degrees of freedom to this problem. Once you've chosen how many horses and pigs to pick, the number of rabbits is forced upon you because you need to add up to 100. So technically, I don't need the 3rd nested loop. I could solve for how many rabbits I need right now. So maybe try that. But I think that's all that I wanted to say for this example. All right. So if we're good, yeah, it's a fun one, I think. So before we go, let's talk about like this idea again, like taking a program, looking at it, staring at it, and figuring out how it's going to execute in our minds, because that's how you get better as a programmer. All right. So let's pretend we have this code with some variables involved, like this is some code here, this is some code here, A, B, C, D. Let's draw a flowchart for this together. All right. I'll walk you through how I think about it, and then I want you to practice. All right. So we start out in the before code, in the before times. And then we come into this giant thing, which is a while loop, right? The very first thing we see is a while loop, and how do while loops execute? They're going to check their condition, and if so, as long as their condition is true, they're going to run their body. That's what we know about while loops. So the next thing that must happen in this program is we check A. A question mark could either be true or false, right? True or it's false. So if it's true, then we're going to run the body of the while loop once, and then come back to check the condition again because maybe it's changed. All right? It's always condition body, condition body. So, all right, the body of the while loop involves running a for loop. Oh, no. So, all right, how do we run a for loop? We do the initialization first, so B happens first. And then a for loop runs like this. It's always condition, body, increment. Repeated as long as that condition is true. Condition, body, increment. Condition, body, increment. So it's going to be CED as long as C is true. So C question mark. If it's true, we do the condition. The body is E. The increment is D, right? And then we always come back to check that condition again. As long as that's true, condition, body, increment. Keeps firing, all right? And then once it's false, right? Once C becomes false, we are done with the for loop, which completes the body of the while loop. what do you do when you're done with a while loop? Body. When you're done with the body of the while loop, you come back to check the condition again, because the while loop is always condition body, condition body, condition body. So if this C was a false answer, we're coming back to the loop, the outer loop, right? If that was false. So that's how it's going to move around. And then finally, we keep doing that a bunch of times, condition body, where it's the inner thing is its own loop. Once A is false, then we're finally done with the loop. It's finished. We go to the after code, right? So after, and that will be how it runs. Question? Yeah.
So say that A is always true, but B is always false, but just keep running that over and over.
Yeah, it would try to run this for loop, because if A is always true, it's always going to keep on running this body, which it'll skip the for loop each time, but it still needs to try to run it once. So it'll run this, it'll do this, run the condition, and then, oh no, I'm done. Let's go back and check A again. Oh, let's do it all over. Okay. Just make the computer really hot. Turn the fan on, right? So it's going to keep on trying to do something, and it's just never going to get anywhere. But it's running code. It's technically running code and doing stuff, thinking hard. Any other questions? This is what I want you to get good at, one way or another. We're going to figure it out. Yeah. It depends on what A, B, C, D, and E are. Eventually, like what would normally happen probably is like you run for each iteration, you run this a few times, right? The for loop a bunch of times, come back, check the condition. Are we still good? Sorry, eventually it becomes false, right? Get in here, run this a few times, eventually it becomes false. If A is still good, we're going to run the body some more, which is the for loop, maybe run it a few times. As many times as we want to do that until like the while loop is finished. So it doesn't have to be an infinite loop. It depends. Yeah. Any other questions? So yeah, these are good examples. I hope they are useful to you. And then, yeah, before we go, here's just a silly meme that my old boss sent me. It has to do with this idea of like trying all the possibilities in a for loop, right? Because like, if you want to make the ultimate peanut butter and jelly, like you do the rows and the columns, different flavors of like sweet things, different flavors of savory peanut buttery things. And then when you bring them together, you have 9 options now, right? So that's the beauty of one of the sides of a nested loop. That is nice. We know about the other one too now that tries all the possibilities and multiplies answers. Okay, those are the 2. So if we are good, that is where I'd like to stop. There's still more. There's still a little bit more to loops, and we'll do that next time. And we will also give you a lab next time and talk about your midterm next time, because we're in week 4 right now. I just want to make sure you know where we are. Week 4 is our current week. Week 6 is our first midterm. I will explain more about it on Thursday. Okay? So that's all I got for us.